So in grade 8, you dealt with integers for the first time. And when I say the word integer, you probably immediately think negative numbers. And I just want to remind you that integers include the negatives, okay? But they don't have to just be negative. You can have positive integers. And it's not any negative numbers. So if you have a fraction that's negative, that's not an integer. Okay, it might have integers in the fraction, but that's a separate issue. Okay, so what do we already know? What do we remember from grade 8 about using negative whole numbers? Right, so I want to remind you about BEDMAS. Okay, so we deal with brackets, and we deal with exponents, and then we do divide and multiplication, and then we do addition and subtraction. And this might mean you want to add your own brackets from time to time, and I'll show you what I mean by that. Okay, just to kind of simplify what's going on in your head. You can see by the calculations we're about to do that they would be extremely easy to do on the calculator. And so obviously this one is going to be without calculator. Okay, now you don't have to avoid using a calculator unless you are expressly told you may not use a calculator. But what I've noticed is that some people think that's a suggestion and not an instruction. I promise you, if an exercise you're doing or something in an exam says do not use a calculator, then it means that the people marking know all the tricks you could use, and they really, really, really want you to do it without using a calculator. And basically the marks are only there for the steps that you do without a calculator. In grade 8, you also worked with surds. Okay, and I want you to treat a surd sign, treat it like a bracket. If there's anything you can do to solve what's inside it before doing anything else, then you need to do that. Okay, you can't simply square it. Some people like to see a square root and then just automatically square. You can't just do that because that's not simplifying. That's doing a completely separate operation, and you can't randomly square. Okay, and then I want you to be aware that if you have things in a binomial form, so if you have, say, a 5 and then you've got -2 plus 3 underneath, it's a good idea to treat a binomial, so something with two numbers or more than two, it's a good idea to actually go and add your brackets, and that's where this skill comes in again, is to treat the top and the bottom of a fraction as though there are implicit brackets in the top and the bottom. So you can't go and do things, you can't cancel the top and the bottom until you've sorted out the top individually and the bottom. And I'll show you what I mean by that now. Okay, the other stuff that you hopefully remember from grade 8 is that a plus times a plus is a positive. A negative times a negative is a positive. And if they are different, you get a negative. Okay, I'll just write the other one up there, even though these are basically the same thing. So my rule is if they're the same, the answer is positive, and if they're different, the answer is negative. Okay, but that is for multiplication. Some people like to apply that to adding and subtracting, and it doesn't work. You can't say, well, if I add two positives, I get a positive. It happened to be true, but the rule isn't actually sound, because if I add a positive and a negative, I do not get a negative. It really depends on which number is bigger. Okay, so let's just make sure we keep the rules tight and we know which ones apply to adding and subtracting and which ones apply to multiplying and dividing. Okay, obviously this includes dividing. Okay, so a positive divided by a positive is also a positive, and so on. Because multiplication and division are basically the same process. The one's going forward, the other one's going backwards. Okay, let's have a look. Right, I'm saying 4 plus -5. So I'm going to remember my number line, and I'm going to think about if 0 is in the middle, I have 4, and I'm going to add -5. There's two ways of looking at this. I can say what this is actually doing. If I add -5, Brackets means times, right? And you probably remember the distributive law that you did in algebra last year. A plus times a minus is a minus. This is actually 4, and the plus times a minus becomes a minus. That's actually 4 minus 5. Okay? Or I can think about it as 4 plus a negative 5. A negative will then go backwards along my number line. So there's my 0. There's 1, 2, 3, 4. And I'm going to go backwards by 5. 1, 2, 3, 4, 5. What would be there? Well, that would be negative 1. Okay, and if you still need your number line, please draw it wherever it is appropriate, or use your ruler if that helps you. If you need to think about going left and right on a number line, then just make sure you've got the tools around you that will help you do that. Question B is saying 4 minus negative 5. Okay, and here I really do think using the distributive law will help you. And by the way, you can check all of these on the calculator. You just have to show things like this step. Okay, right, so I'm going to say, well, 4, that's the same as saying 4. What's a minus times a minus? And why am I saying minus times minus? Because brackets, if they're stuck together, or things on either side of a bracket, brackets means times. Okay, so it's actually 4 minus times a minus is a plus 5. Or you can think about I'm minusing a negative, which is actually adding, right? Okay, so that one's going to be 9. Question C, I'm now going to switch it up and I'm going to say a negative times a negative. Okay, and you'll probably then know immediately what to do with that. Negative times a negative is a positive answer, and 4 times 5 is 20. Try not to get too confused between timesing and the rules for that and adding. And the way that you can avoid that confusion is just slowing it down a little bit. Okay, now question D, how is that different to question C? Well, I'm saying, again, brackets means times. I'm actually saying negative 5 times 4. And why would I go and write out all of these steps? Well, because I need to prove I'm not using a calculator. For question C, I can't actually prove I didn't use a calculator. There are no other steps I can show. But we wouldn't give you a question like that in a test. This is just a way of me getting you into the topic and you understanding the basic principles. Well, a negative times a positive is negative, and 5 times 4 is 20. Let's look at these two. Questions E and F. They are not the same thing. Here, I'm squaring only the 3. In question F, I'm squaring the negative and the 3. Okay, so here I've got to leave that negative where it is. And then I need to square the 3. So it's negative 3 squared. 3 squared is 9. And it has to be negative because the negative applies outside. Okay, so let's look at BEDMAS again. BEDMAS means do the brackets first, then the exponents, and only then can we deal with the negatives or positives, because those are the things that are being multiplied in. And here we have a negative, it's basically like negative 1 times by 3 squared. I'm rewriting it like that to show you how I'm thinking about it. So this is times, the negative is multiplying in, but only after we square it and we apply the exponent. Okay, this one's different. Here, to apply the exponent means to apply it to everything inside the bracket, because that's how exponents are written. So that means I square the negative. This is the same as saying negative 3 times negative 3. Whereas this one is the same as saying negative 3 times 3. So I don't know if that helps. Okay, negative times negative is a positive, and 3 times 3 is 9. So my answer to question E will be a negative 9, but F will be a positive 9 because the negative also got squared. Okay, can we actually do question G? Well, type that into the calculator to just confirm, but I can't square root a -8 because that's a square root, hey? It's a square root. Because when there isn't any number there by the root sign, it means it's a square root. You can never square root a negative. This is actually, going back to our definitions of different types of numbers, it's actually a non-real number. Okay, if you do AP Maths one day, you'll deal with non-real numbers. But for now, let's not worry about those guys. Okay, but I just want to be devil's advocate and say, but what if it was a cube root? What would that be? You can test it on the calculator. This is one of those ones we actually need you to know off by heart. That would be -2. Okay. All right. Question H. Right, here we have a fraction. And I immediately am going to start adding brackets. Okay, because I want to treat the numerator and the denominator as separate things. I cannot cancel anything. I can't cancel the 5 and the 10. None of that can happen because of these pluses and minuses and because of basic BEDMAS rules. So let me just handle the top, handle the bottom, and then see what can cancel. Okay, -4 plus 5, we did that, or we did something like that a bit earlier. -4 plus 5, I'm going to be on this side of the number line, and I'm going to go 1, 2, 3, 4 to get to 0, and then I'm going to go another one, and that's going to be at +1. Okay, -4 plus 5 is 1, so I've sorted out the numerator. This is a mess at the bottom. Let me just rewrite it for myself. -9 minus -10. What is that actually? Minus bracket, minus. Bracket means times. That's actually -9 as it was. Minus times a minus is a plus 10. Okay. And this would be a really good example of something we could give you in a test where you have to show these steps. Okay. So -4 plus 5, we've got our 1 on top, and at the bottom, -9 plus 10 is also going to give me 1, and my answer is 1. And guys, I would show this step completely, because then it is really clear that you are doing every little thing without using a calculator. Okay, let's look at how BEDMAS applies to this one. Something that I've learned that works for a lot of people is to bracket the divide and multiply stuff, mainly the multiply, because divide tends to be in the form of a fraction. Okay, and do that. It just helps you see the fact that divide and times must come before minusing. We can't go 2 minus 3, get an answer of -1, and then multiply by the 3 squared. You have to deal with the times first, okay? And I find most people really prefer putting in those brackets. So I'm going to say that is actually 2 minus, okay, what's 3 times 3 squared? 3 times, let's do one step at a time. 3 squared is 9, okay? And you can see I'm adding in what looks like rather unnecessary steps. Well, that's because it's a non-calculator question. So I'm always going to be a little bit extra when it comes to proving I didn't use a calculator. Okay, so I'm going to say 2 minus 3 times 9 is 27. Okay, so now I can do my final answer. It's going to be 2 minus 27, so I'm going to have -25. Okay, but I just want to explain why I dropped the brackets, because what I did is I got an answer for my bracket, so there's no need to go and have brackets there by the 27. That's just going to be confusing. When you sort brackets, I like to say, then you drop them. Sort and drop. Okay, let's look at this one. This is quite hectic. Okay, remember we're going to treat a square root like it is a bracket and try and do it, simplify it before we move on. Let's see if that's possible. And then I'm looking at a whole bunch of things. I'm looking at a times going on there, and then there's a minus. Okay. So I need to just be careful. I can't say -6 plus 2 now, because that is attached there. This multiplication attaches very fiercely. So this, remember brackets is one term. That thing that I've put into square green brackets, that has got to be dealt with before I subtract or add anything. Okay, so let's go. I'm going to copy and paste my -6. Then I'm going to say plus. Right, let's simplify what's in here, and then we'll simplify even further on the next line. What is root 4? It's 2. I'm sure you know that. Times, remember brackets first, BEDMAS. What is 4 minus 9? 4 minus 9 is negative 5. So it's actually 2 times negative 5. You could put baby brackets in there as well if you wanted to. And now I'm going to minus negative 5. Okay, let me do that step. Minus a negative, or negative, bracket means times. Negative times negative is actually positive 5. Okay. Negative 6 plus, what is this answer? 2 times negative 5, it's a positive 2, times a negative 5, so it's going to be negative 10. I'm going to just keep the brackets there because I've got a plus and a minus next to each other, and that can be super confusing. And I'm now plusing 5 on that side. Okay, so it's negative 6 plus times a minus, because brackets means times, plus times a minus is a minus. So I've actually ended up with 6 minus 10 plus 5. And that is pretty straightforward. That you just do from left to right in the order in which it is done. Negative 6 minus 10 gives me negative 16, plus 5 gives me negative 11. And you know what? If you did this step on the calculator, we would never know. Right. Last one is dealing with this surd like it is a bracket, dealing with the numerator like a bracket, and the denominator like a bracket. Okay, here's our negative 3 squared. It seems to come up a lot. Alright, so negative 3 squared, remember I'm squaring the 3, not the negative, so that's going to be negative whatever 3 squared is, which is 9. Okay, now I can times this surd, which I'm going to need to work with. What is 9 plus 16? Treat it like a bracket. It is 25. Okay, so that's fine. And I'm also treating that like a bracket. Plus, let's simplify the top and simplify the bottom. Negative 3 times 2 to the 3. Okay, so it's negative 3. I must do the exponent first. 2 to the power of 3 is 8. And then negative 2 minus 6 is negative 8 on the bottom. Okay, now let's add some bigger brackets here, because here I've got 3 terms. Well, it's sort of like 3 terms, but actually it's 2 because these guys are being multiplied. And then this one's being added. So I must deal with the multiplication first. Okay, so actually this is negative 9 times, right, what is root 25? It is 5. Okay, so that must be done. Then I can add however this simplifies. Negative 3 times 8, it's a times table, it's going to be negative 24 over negative 8. That can still be simplified. Okay, what about what's happening here? Negative 9 times 5 will be, also times table, negative 45 plus, okay, here we can do some cancelling. The negatives cancel. You can look at it that way, or you can say negative divided by a negative is a positive. And then 8 goes into itself once, and into 24 3 times. So actually that's 3 over 1, which is actually 3, isn't it? So I've got negative 45 plus 3, and my answer will be negative 42.